In the Great Hall, the James Webb Space Telescope has captured something truly amazing. A moon resembling a city on Earth, shining on the exoplanet Proxima Centauri b, 7 trillion miles away. Are you ready to face what lies beyond the stars? Could we be seeing an advanced world up close, other than our own? New observations from the James Webb Telescope have revealed that this is not just a random flash of light, but a signal from an advanced world on Proxima Centauri b. All movement, all potential so far away is closer to us. The greatest revelation in human history is contact with another world. This quiet corner of space is now teeming with life. As the data becomes available, we will face a moment when history is rewritten. Proxima Centauri b is shining with a light comparable to major cities on Earth, exciting scientists. Could this light point to intelligent life that organizes itself into communities we never imagined? Columbia University cosmologist David Keeping considers Proxima Centauri b to be a complex object. Unlike most rocky planets, which absorb sunlight and emit infrared energy, this planet is different because of its unique relationship to its star, Proxima Centauri. This unusual behavior has attracted scientific interest. The discovery demonstrates the power of the James Webb Space Telescope. The ability to detect infrared is crucial to capturing this bright light and revealing how much light we can still see. The heat signature of Proxima Centauri b provides important information about its atmosphere, indicating whether life could exist there. The James Webb Space Telescope is ideal for observing tiny twinkles in the dark of space, and is a great tool for observing city lights forming on the dark side of Proxima Centauri b. This telescope can detect artificial light if it can detect it. It emits in a specific frequency range and is much brighter than starlight. Proxima Centauri b is closely related to its star and experiences warm day and cold night cycles like Earth. If the planet had no atmosphere, this temperature difference would be enormous. However, if the winds or oceans were too extreme, the day side would be very hot and the night side would be dry. These differences help scientists study the Earth's atmosphere. The James Webb Space Telescope can use its powerful imaging capabilities to estimate the Earth's temperature, giving scientists important clues about its climate. The telescope's orbit is also synchronized with Proxima Centauri b's orbit, allowing observations of the planet's orbit every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to study its chemistry to see if it could support life. Signs such as oxygen, water vapor, and methane could indicate that the planet has a climate favorable for life. Observing these features would increase the likelihood that life exists on Proxima Centauri b and lead to more detailed studies of its atmosphere. The James Webb Space Telescope could study powerful, but potentially habitable nearby planets. To get a more complete view, scientists are looking to the Extremely Large Telescope, ELT, which is scheduled to be operational in 2028. Looking to the future, astronomers hope that the new telescope will be able to reduce the glare from stars and structures. Rotating planets are easier to observe, similar to shielding your eyes from the sun to see them more clearly. As stars dim, advanced telescopes will be able to better image the brightness of distant planets, allowing scientists to better study their atmospheres and assess whether they could harbor life. However, it is difficult to distinguish between signs of life and environmental activity. Scientists must carefully separate gases produced by living organisms from gases produced by volcanic activity and other environmental changes. The James Webb Space Telescope offers a new way to observe Earth. The ability to peer deep into space brings us closer to understanding the universe as a whole and our place in it. The question of whether we are alone in the world has driven scientific research for centuries. Today, the James Webb Space Telescope continues to study various planets and moons, searching for signs of life beyond Earth. Life is evolving in other parts of the world, too, and many people are excited by the prospect of finding life beyond our borders. In 1984, American scientists Jill Tarter and Thomas Pearson founded the Search for Extraterrestrial Intelligence, SETI, a non-profit organization that listens to radio broadcasts from this region. The Allen Telescopic Array in California is at the center of the effort, using radio waves that can travel long distances without fading. SETI has still not found any definitive evidence of extraterrestrial life despite more than 30 years of listening. Either way, Jill Tarter is fine with it. Given today's advanced technology, she believes a breakthrough is inevitable. She dreams of a world where we work together to answer the age-old question: are we alone in the world? The excitement was palpable when NASA recently announced that the James Webb Space Telescope may have detected the light of an artificial city on a nearby planet. The telescope, located 1,000,000 miles from Earth, is essential to space exploration. It provides detailed information about the oldest parts of the world and is designed to capture information that has never been seen before. This allows scientists to learn more about the nature of galaxies, stars, and planets. Astronomers use advanced equipment on the James Webb, including cameras and precision filters, to absorb light from stars and planets. The telescope helps scientists study the wavelengths of light to determine the physical and chemical properties of distant worlds. But surprisingly, the James Webb Space Telescope does more than just observe. It studies the atmospheres of various planets to find even the smallest traces of life. This lens of ancient world exploration will lead us to a world of new discoveries. Scientists have made great discoveries and discovered more hidden objects in our galaxy than we ever thought possible. These discoveries challenge our current understanding of the creation and evolution of the universe. With each new discovery, we get closer to understanding what lies beyond Earth and in the farthest corners of the universe. In the search for extraterrestrial life, scientists focus on planets orbiting their own stars. If signs of life are confirmed, it could change our understanding of the world and our behavior within it. Advances in telescopes and observation technology have made the search for extraterrestrial life a reality. Astronomers not only study the properties of distant planets, but also explore their potential to support life. One of the earliest developments was spectroscopy, a technique for analyzing light emitted or absorbed by objects in space. By studying the light emitted by exoplanets, scientists can determine the chemical composition of their atmospheres and identify gases such as hydrogen, helium, and nitrogen. These results can help assess whether the exoplanets could support life. Scientists are also studying the climates of exoplanets, which can provide clues to their environments. For example, seasonal changes indicate the availability of water, which is essential for life. Extreme weather events, such as storms or temperature changes, can affect the existence of Earth. Searching for biosignatures or signs of life is a priority. In addition to traditional markers such as oxygen and methane, researchers are studying other biological markers such as complex carbon molecules. The optical properties of the James Webb Space Telescope are ideal for finding these signs of life. In addition to direct observations, theoretical models help guide the search for extraterrestrial life. These models predict what features and conditions might exist on exoplanets based on known laws of physics and chemistry. They also inform the design of experiments and missions to test these predictions. Artificial intelligence, AI, is also revolutionizing space exploration. AI algorithms are increasingly being used to analyze data collected by telescopes and identify patterns and signals that human researchers might miss. This will expand our understanding of distant worlds. International collaboration plays a vital role in accelerating space exploration. Scientists around the world are sharing data, resources, and expertise, accelerating discovery and expanding our understanding of exoplanets. As space technology and scientific methods continue to advance, we are on the verge of answering one of humanity's oldest questions. Are we alone in the universe? Advances in this field reflect the tremendous progress we have made in exploring the world and understanding our place in it.